1 and Maths 102 and 121 comprises questions from trigonometry, differentiation, application of differentiation, integrations, and calculus in general. So let's dive into it by looking at question 1. Please, this is STEM of Africa. If you have not subscribed, please do so. We have exciting content such as this. So let's look at question 1. Say a distance x meter traveled in t seconds by a particle in a straight line is given by the relations x equals to t2 cubed minus 10t. So find its speed at t equals to 3 seconds. So we're looking for the speed. They gave us the distance as a function of time. So let's see. Our x, question 1, our x is 2t cubed minus 10t. To find v is unknown. We have to find v at t equals to 3 seconds. In elementary physics, you have been told that velocity is, or speed, is displacement over time. So my v is changing x over changing t, which is the x over the t. That will give us a v. So if I differentiate this, the x t, which is v, I'm going to have 6t squared minus 10t. If I differentiate that, that's what I have. I hope you know formula of differentiation, nx n minus 1. If y is x raised to the power n, that's what we have. We bring out the power to multiply any variable there. And this is 10 bracket 1. So I'm having v as 60 squared minus 10. So at t equals to 3, what are we having? We're going to have v equals to 6 bracket 3 raised to the power 2 minus 10. So 3 raised to the power 2, that will give us 9. 9 times 6, that is 54. So we're having 54 minus 10. V will give us 44 meters per second. So the answer to question 1 is simply 44 meters per second. That satisfies option C. So let's look at question 2. It said if y equals to x squared cos x, you find the y, the x. So let's go to question 2. We are given that if y is x squared cos x. So this is a product rule. The first variable is x, the second variable is u, and the second variable is v. So I will write my u equals to x squared and v equals to cos x. So if I differentiate u with respect to x, I'm going to have the u over the x. That will give us 2x. If I differentiate v with respect to x, I'm going to have the v over the x. That will give us minus sine x. Differentiate cos will give negative sign. So if for a product rule, I will equate the formula dy dx. That will give us v du over the x plus u dv over the x. So if I substitute, where's my v now? Cos x times du dx is 2x plus ux squared times minus sine x as our dv dx. So if I simplify, that will give me 2x cos x minus x squared sine x. So our answer is 2x cos x minus x squared sine x. Let's check that out. 2x cos x minus x squared sine x is satisfied option C. It's satisfied option C. So let's look at question 3. Let's look at question 3. Question 3 says, a function is said to be continuous at x equals to a if the limit of s tends to a is giving us f of x, which satisfied option E. So look at question 4. We are told okay, this course is all about differentiation, integration, and the application of differentiation integrations, including inverse differentiations. That's what the course is all about. So, and limits, most importantly, and the limits. So that's what we are doing here. And we are using questions from Natural State Federal University of Latvia. That's the question we are using as a sample, which cover every school. If you are doing the differential integrations, the course content are the same. So let's go to question 4. It says you find the derivative of y equals to of y if y is ln open bracket 1 plus 2 raised to power 2. Y is equals to ln 1 plus 2x raised to power 2. So I can rewrite this as 2 ln 1 plus 2x. If you apply the concept of logarithm, that's what you have. You get 2 ln 1 plus 2x. So in this case, it's a function of function. I can say let u be the function of x, 1 plus 2x. Then my y becomes 2 ln u. 2 ln u, because we take 1 plus 2s as u, becomes 2 ln u. So I will differentiate u with respect to s in the first case. That will give us du dx. The u dx will give us 2. I'll differentiate y with respect to the u. I will have the y du. That will give us 2 dots. If I differentiate ln u, is 1 over u. It can be written as 2 over u. Because 2 times 1 is 2. So I will now equate the formula for function of function that says dy dx is equals to dy du dot all times du dx. So if I impute the value, what is my dy du now? 2 over u times du dx is 2. So we are having 4 over u. But don't forget, our u was 1 plus 2x. So I will substitute it in place of u. So the final result will be 4 over 1 plus 2x. We're having 4 over 1 plus 2x. Let's go back and see which option satisfies that. 4 over 1 plus 2x, which is option C. So we have too many C already, which is option C. The answer is 4 over 1 plus 2x. Question 5 happens to be a limit. Question 5 happens to be a limit. It says lim x tends to 1 of x squared minus 4 over x minus 2. So we have lim x tends to 1 of x squared minus 4 over x minus 2. So when you see a limit like this, you can first of all simplify it. So I will have this as x squared minus 2 squared over x minus 2. So I will apply the difference of 2 squared to the numerator. So I have a lim x tends to 1. So give me x minus 2 x plus of 2 over x minus 2. So you agree with me that x minus 2, we cancel x minus 2. I'm left with lim x tends to 1 of x plus of 2. So and I see x, I'm substituting 1. So my result becomes 1 plus 2. The final result will give us 3. So the result to that limit, the answer is simply 3, which is option C also. Question 6, they gave us that dds of gs equals to c, which is constant. Gs is 0, then gs is a what? Is f of x. Gs means gs will contain a variable x, because if I integrate the constant, I'm adding x to it, become f of x become f of x, which is option D. So question 7, say we have f function of g, function of 2, if f of u is this and f of g is that. So they gave us f of u, our f of u as the square root of u plus 2, then g of u is given to us as u squared plus 2. So we're asked to find f of function of g, function of 2. I can write this as f g of 2. I can also write it as this. So let's first of all get our g of 2. G of 2 will be 2 squared plus 2, which is 4 plus 2. The answer is 6. So our g of 2 is 6. So I'm having f now. The whole of this now is 2. F of 6, which is square root of 6 plus 2. That will give us square root of 8. If I apply sod, I can write this as 4 times of 2. The result is 2 root 2. So our answer is 2 root 2. Or, okay, here is 1, not, here is 1, not 2. That means I'll change it to 1. So I'm having the square root of 7. There will be no need for this. So our answer is the square root of 7. So let's go to question 8. Let's go to question 8. We are asked to integrate. We are asked to integrate 2 pi over 4, then to 0 cos x dx. 2 pi over 4 to 0 cos x dx. So let's integrate that. So we're having integral of 2 pi over 4 to 0 cos x dx. So from the standard integration form, if you integrate cos x, you have sine x. So we have this as sine x to the upper limit to the lower limit plus c. So my s now is 2 pi over 4 and s is also 0. So this is what we imply, sine 2 pi over 4 plus c minus, when s is 0, sine 0 plus c. This is what we have. So if I simplify, here will give me sine 2 pi over 4 plus c minus sine 0 minus c, such that minus c and plus c can remove themselves. So I'm left with sine 2 pi over 4 minus sine 0. So pi in calculus is 180. So what you have to do is to press 2 times 180 degrees divided by 4. That will give, that's why I'm having sine 90 and sine 90 degrees minus sine 0. And sine 90 is 1, sine 0 is 0. So 1 minus 0, the result is 1. So solution to that question is 1, which is option D. So let's look at the question 9. It said a function g tends to a is said to be monotonically increasing on the interval of a to b. If it's increasing, that means the first one must be greater than the second. First one must be greater than the second. Monotonically, to be mono meaning single. Okay? So it simply means that the first function and the second function as 1 and 1. So that result will give us option A. Then look at question 10. Now look at question 10. So which of the following function does d cube y over dx cube is equals to dy dx? So the only function that can satisfy that is Roman figure 3. Let's check. Anyway, let's check Roman figure 1 down to Roman figure 3 to be sure. Not that I'm just saying it. Roman figure 1, we have y equals to cos x. Numeral 1, we have y is equals to cos x. If I differentiate this, dy dx will give me minus sine x. Then if I differentiate again, the square y over dx squared, which is second derivative, I'm going to have minus cos x. If I divide the second derivative, that will give us the third derivative. That will give us minus into minus sine x. The result is sine x. So you can see that our d cube y over dx cube is not equal to our dy dx. Why? This is positive, why this is negative. So the first condition did not hold. So this man did not hold. So let's strike it out. So let's look at the second condition. So you can ask questions, you have any area of interest. So let's look at math got 2. We have this time y is equals to exponential minus x. So let's differentiate. And to have the first derivative, our dy dx will give me minus exponential minus x. So let's differentiate, let's obtain our second derivative from the first. So I'm having d square y over dx squared. I'm going to have, the minus side will come down also. That will now give a positive minus x. Then d cube y over dx squared. If I differentiate again, I'm going to have minus exponential minus x. So we're having d cube y over dx squared is equals to our dy dx, because the two values are the same. So the second condition hold. Second condition hold. And also the third condition will hold. When you differentiate exponential s in multiple cases, you also give exponential s. The second condition, so we have 2 and 3, which is option E. So now look at question 11. So one of the following is not a rule for finding the limit of a function at infinity. Well, it's not a rule of finding the limit of a function at infinity. The first one is a rule. The second is a rule. Then the third is a rule. The fourth is a rule where limit of a constant at tends to infinity will give us a constant. Solution is option E. Let's look at question 12. So we should integrate exponential y plus exponential 2y with respect to y. We want to integrate exponential y plus exponential 2y with respect to y. So anytime you integrate one differentiate exponential y, it will give you exponential y. So how do we integrate exponential 2y? So it's not something you should cram, it's good you know the procedure. So if I want to declare exponential 2y, this is how we go by it. So to integrate this, I will also say let u equals to 2y. I will differentiate this, du dy, that will give us 2. So let me make dy the subject formula. My dy will give me du over 2. This is now the value of the y. So I will substitute it. Here I have the y, which is here. In my NURC the y, I'm putting du over 2. So I'm going to have integral exponential u dot du over 2, which is 1 over 2 integral of exponential u du. So like I said, if you integrate exponential u or exponential x, it gives the same thing. So my result is now 1 over 2 exponential u plus c. But what is our u? Remember, our u is 2x. I'm having 1 over 2 exponential 2y plus c. So what is the point? If I integrate this, I'm having exponential y. If I integrate this, I'm having exponential 2y over 2 plus c. So let's check the option. Let's see which of them satisfy that, which is option B, satisfy the solution. So here we go again. Definite integral, where you're giving the upper, the lower limit of 2x plus 1 dx. So let's integrate that. We have integral 5 to 1, 2x plus 1 dx. So if I integrate, here is raised to power 1, you should take notes. So I will have this as 2x, 1 plus 1 over 1 plus 1. If you integrate the constant to become x, I will write my upper limit and lower limit plus c. So if I simplify that, I'm going to have 2x squared over 2 plus x, upper and lower limit plus c. So we cancel 2. I'm left with x squared plus x, 5 to 1 plus c. So when s is 5, I'm going to have 5 squared plus 5 minus, when s is 1, I'm going to have 1 squared plus 1. I'm going to have 25 plus 5 minus 2. The answer is now 28. So the solution to that question is 28, which satisfy option A. So let's look at question 14. We are asked to find the y dx if y is the tan inverse of x. We are given y as the tan inverse of x. We'll find the y dx. So our y is given to us as tan inverse of x. So I can write this, if you are used to trigonometry, I can write this as tan y equals to x. Because if I want to find y, I will take the tan inverse of x. So the two are the same. So I'll differentiate the left-hand side and also the right-hand side. If I differentiate the left-hand side, if I differentiate tan, it will give me sec square. Sec square y dy over dx. Then if I differentiate x, I have 1. So what we are doing here, we are applying implicit function. And yet, when you differentiate y, you add the y dx. So this one implies that dy dx is equals to 1 over sec square y. But from trigonometric identity, we are told that 1 plus tan square y is equals to sec square y. And our tan y, don't forget our tan y is x. I'm having 1 plus x squared equals to sec square y. So in place of sec square y, I can replace it with 1 plus x squared. So my dy dx will give me 1 over 1 plus x squared. That's now the solution to that question. Which option satisfies that? Option B satisfies that. Option B. Okay? He said, is the function of this is odd or even? So we have 5 and 3 as the power, then 1. So no doubt this is an odd function. It's an odd function. Option E. It's an odd function. Now, you say if f of y is this, we are asked to find y. So find y for which the second derivative of y is 0. So we are going to find the second derivative and equate it to 0. So let's see how that goes. We are given f of y. Our f of y is 10 over 2 y squared minus exponential y So let's differentiate this. F prime of y means the first derivative. That will give us 20y over 2 minus exponential y. Like I've said, so if I enter differentiate exponential y, it remains exponential y. So I can cancel out. I'm having 10 y minus exponential y. So let's get the second derivative from the first. It's my second derivative now, which is equal to 0. The value becomes 10 minus exponential y. So I can make exponential y the subject formula. So I'm having 0 plus exponential y is equals to 10. So exponential y will give us 10. So how do we find y from here? I will take the ln of both sides, which is the natural logarithm of both sides. So I will have ln exponential y equals to ln 10. So my y will go back into the law of logarithm. I'm having y ln e is equals to ln 10. Ln e is 1, which is log e base e. Therefore, my y is simply ln 10. Let's go back. The answer to that question is option C. So let's look at question 17. It said integrate b raised to the power n dx. We are asked to integrate b raised to the power n dx. So let's say our u, for instance, is b raised to the power n. Okay? So to integrate this, I will take the ln of both. Integration this, I will take the ln on both sides. I will have ln u is equals to ln b raised to the power n. So ln u will give us n ln b. So you can ask questions if you have any. So if I differentiate both sides, I'm having 1 over u du is equals du over the n is equals to, if I differentiate n, I'm going to have ln b. So what is our du dn now? Du dn will give us u ln b. And what is our u? Is this? So I'm having b raised to the power n ln b. b raised to the power n ln b. So I'm having now integral u dx. Integral u dx. So since we're integrating with respect to the x, there is no viable answer to this question except this x is n. That's the only way we can have a solution to it. Except the n, the x there is n. So if the n is x, you are going to have the solution should be option C. There's no variable, otherwise the answer ought to be just x b raised to the power n. If you're integrating with respect to x, that's what it's ought to have. So let's look at question 18. So which of the following methods, which of the following a method of integration is step? We have integration by parts, we have integration by substitution, we have integration by partial fraction. We don't have anything like quotient through in integration. That is under differentiation. Okay? Now we are asked to find the area of the region closed by the curve. They gave us y as s squared and y as s plus 6. I want to get the area. The area of a curve is simply BA y dx. That's the area of a curve. This one is upper limit, or this one is the lower limit. They gave us y as x squared and y as x plus 6. So I can equate it. So I'm going to have x squared is equals to x plus 6. So let's substitute this y in place of this y. That's why I'm having x squared equals to x plus 6. So if I rearrange this, I will have x squared plus x, I will have have x squared minus x minus 6 equals to 0. If I should transfer the positive 6 and negative 6 to the left hand side, it becomes 0. So what we have here is nothing but a quadratic equation we can solve by using factorization or formula, but factorization should be better. So factorize this, I will have x minus 3 and x plus 2. So the result will give us x minus 3 as 0 or x plus 2 as 0. So x will give me positive 3 and negative 2. Positive 3 and negative 2, that will be our x. So the upper limit now, I'll write this one as 3 to minus 2 into x squared minus x minus 6 dx, which is this entire function. I can also equate it to y. So we have to integrate x squared minus x minus 6 dx. If I integrate that, I'm going to have, if I integrate x squared, I will have s3 over 3. If I integrate s, I'm having s2 over 2. If I integrate 6s, I'm adding x to it. 3 to minus 2 plus c. Anytime you integrate, you must add your constant c. So let's substitute when s is 3. I'm going to have 3 raised to power 3 over 3 minus 3 squared over 2 minus 6 bracket 3. Let's also substitute s as minus 2 raised to power 3 over 3 minus into minus 2 raised to power 2 over 2 minus 6 bracket minus 6 bracket minus 2. So minus 3 raised to power 3 will give us 27. I'm having 27 over 3 minus 9 over 2 minus 18. Here I'm having minus 8 over 3 minus 4 over 2 plus 12. So if you take LCM on the first one, the LCM will be 6. So if you simplify that, we are going to have, let me simplify from my end. So the first case will give us coming. Okay, let's just do it together. The LCM is 6. So 6 into 3 is 2. 2 times 27 is 54. Minus 6 into 2 is 3. 3 times 9 is 27. Minus, yes, over 1. 6 is 1 is 6. Times 18. That will give us 108. Do the same thing here. The LCM is also 6. I'm having minus 16 minus 12 plus 72. So I'm having 54 minus 27 minus 108. I'm having minus 81 over 6. Second one, minus 16 minus 12 plus 72. I'm having minus 76 over 6. So minus 81 minus 76, that will give us minus 157 divided by 6. So our answer is 157 over 6. So solution is B. A, I mean. Now they gave us that if sine y plus x squared y equals to 30, so you should find the y dx. They gave us sine y plus x squared y is equals to 30. We are looking for the y dx. So without being told, this is an implicit function. When you have a function comprises x and y, it becomes an implicit function. So I will differentiate y. Anytime I'm differentiating y, I add the y dx. So I differentiate sine y, going to give us cos y. I will add the y dx plus If I differentiate x squared, it will give me 2x. Then I will leave the y as constant. My y become a constant. Then plus, if I differentiate y, you will give me 1. I will add the x as a constant minus the y dx. Because I'm differentiating y, I'll put the y dx. Then if I change the constant, the result is 0. So I can make the y dx the subject formula. So I'm having cos y dy dx plus x squared dy dx is equals to 0 minus 2xy. So if I factorize what's coming from the left hand side, which about the y dx is common, I will have cos y plus x squared is equals to minus 2xy. Therefore, my dy dx is now minus 2xy over cos y plus x squared. Is that the answer? Minus 2xy over cos y plus x squared. Let's check that out. Minus 2xy over x plus cos y, which is option B. Let's check question 21. Question 21 said you should find the square y by the x squared at x equals to 9 of if y is root x. So they gave us y as square root of x. So I will write this as x raised to the power half. We follow the law of indices. So now we differentiate it. This one implies that the y dx, I will have 1 over 2x minus 1 over 2. This is now the first derivative. So let's find the second derivative. That will give us the square y over the x squared. I'm going to have minus 1 over 4x minus 3 over 2. Say at x equals to 9. So area I see x, I put 9. I'm having minus 1 over 4x, which is 9, minus 3 over 2. In minus 1 over 4, 3 raised to the power 2 is 9 times minus 3 over 2. 2 can cancel 2. I'm left with minus 1 over 4 times 3 raised to the power minus 3. So if I apply the law of indices to that, I'm having minus 1 over 4 times 1 over 27, which is minus 1 over, then multiply 4 with 27, 4 times 27, that will give us 108. So the result is minus 1 over 108. Let's check that out. Minus 1 over 108, which is option C. Let's check question 22. It says if f of y is 9y plus 13, find f of 3y. So if our f of y they give to us as 9y plus 13. So if I differentiate it now, f1 of y will just give us 9. The 13 is constant, that is 0. So there's no way we are substituting y as f of 3. There's no way we are substituting a y as f of 3. Therefore, our answer is just 9. The answer is simply 9. So let us integrate number 23. So let us integrate number 23. We are given to integrate ln y over y dy. So anytime you see integration like this, always take the complex variable as your u. The complex variable here is ln y. So I will say u is equals to ln y. I'll differentiate it. The u dy will give me 1 over y. So let me make the y the subject formula. My dy will give me what? My dy will give me y du. So let's substitute it in place of the y. I see the y, I'm putting y du. So I'm having integral. We took the whole of this as u over y times y du. Y cancel y, I'm left with integral u du. raised to power 1. If I integrate it, I'm going to have u squared over 2 plus c. Where's our u? It's ln y. I'm having ln y raised to power 2 over 2 plus c. That is our answer. Let's check it. I'm having ln y raised to power 2. This time around, I use k as a constant. It does not change anything. So that is the solution to question 23. So let's look out for question 24. If you have any question, you may ask. Let's look at question. And also subscribe to the channel. Just stop. Screen sharing has stopped. So let's look at question 24. Hang on, the screen sharing has stopped. Hang on a minute, trying to bring it back. I'm almost there. Okay, let's check question 24. Here we go. Question 24 is also a limit. So to substitute x tends to x minus 4. I'm seeing minus 4 there. I'm having ln. I'm having ln x tends to minus 4 of x squared plus 8x plus 16 over x plus 4. So if you substitute minus 4 into a denominator, it would use 0. And you're not allowed to have 0 as far as limit is concerned at the denominator. For that reason, I will factorize the numerator. If I factorize the numerator, the factor will be s plus 4 and s plus 4 divided by s plus 4. So s plus 4 can cancel s plus 4. I'm left with ln s tends to minus 4 of s plus 4. So here I see s, I put minus 4. I'm having minus 4 plus 4. The result is 0. That is option A. Our answer is 0. Then question 25. We are asked to find y prime, which is the derivative of y, if y equals to square root, if y equals to tan the root of x. I give you y as tan the root of x. So my u becomes root x and y becomes tan u. So I'll differentiate the first one, which is du dx. That will give us 1 over 2 root x. We've done that earlier. 1 over 2 root x. Then I'll differentiate the second, dy du. That will give us sec square u. So I will apply the formula of function of function. I'm having dy dx equals to dy du times du dx, which is sec square u times 1 over 2 root x, which is sec square u over 2 root x. Because it sec square u multiply 1 give us sec square u. What's our u? Our u was root x. I'm having sec square root x over 2 root x. Let's check that. Sec square root x over 2 root x, which is option A. So you find the limit of x tends to 0 of sine x over x. This is a special limit. If you have it, the result is always 1. So it's gotten using Maclaurin series or Taylor series. So the result will give you 1. You call it, it's fall under special limit. Then look at question 27. We have, so you should find this square y over the x square if f of x equals to s cubed plus 1 and s squared minus 1. Remember, your f of s is always y. So in place of y now, I can change it to f of x. My f of x now will be written as s cubed plus 1 into s squared minus 1. The easiest way to do this is to expand. Instead of using a product rule, just to expand it. Y will give us s to the power 5 minus s cubed plus s squared minus 1. So I can now differentiate dy dx now. Will give us 5s4 minus 3s squared plus 2x. This is the first derivative. Let's get the second derivative, the square y over dx squared. What did you ask us to find? Second derivative. I'll get it from the first derivative, which is 20x to the power 3 minus 6x plus 2. This is the answer, 20x cubed minus 6x plus 2. So, fortunately, we don't have any result here. There's no solution to question 27. So 28, we should evaluate the integral of s squared x dx. So if you integrate s squared x, you give you minus cot x. Those are standard integrals. Those will fall under standard integrations. You say a polynomial function are dashed at every point, are continuous at every point. Now, number 30, so we should find, for the function f of s equals to 2s plus 1, find the range when the domain is minus 1, 0, and 1. Give of f of s as 2s plus 1, f of s as 2x plus 1. We have to get the range now. It gave us the domain as minus 1, 0, and 1, minus 1, 0, and 1. So meaning s is, I will start with s equals to minus 1. I'm having f of minus 1. Give me 2 bracket minus 1 plus 1, which minus 2 plus 1, the result is minus 1. Then when s is 0, f of 0 becomes 2 bracket 0 plus 1, which is 0 plus 1, the result is 1. Then f of 1, I'm having 2 bracket 1 plus 1, which is 2 plus 1 plus 3. So the range is minus 1, 1, and 3. Minus 1, 1, and 3, which is option C. So I've taken question 1 to 30. This is all we can take for today. If you have any question, put it on the comment section. Like, subscribe, and recommend this channel to others. Call it STEM of Africa. And you can also take your time to solve the rest. Anyone you don't understand, you can solve. Post it to us on the comment section. We will be there to answer them. We also do tutorials. If you want one-on-one tutorials, you can contact us through the comment section. You will be taken care of. Thank you for watching.